All right, welcome to lesson number 4. In this lesson, we're going to build on the knowledge that we've gained so far in working with the select statement. We have a bunch of questions being posed of us by our business partners, which is very common. Once we have access to a database, we're always going to be asked questions about the data that's contained in it. These are somewhat simple and easier questions. They do get a little bit more difficult in complexity. But let's talk about each one as we work through them. I recommend that you try each one out yourself first. Pause this video, try it out, see if you can get it correct, and then play and see what the answer is. Again, we're going to want to use our diagram to help us and review our diagram as we get familiar with this. Over time, when you work with a particular database, you'll start to memorize the entities, the attributes, and become like second nature to you. But since this one is fairly new to us, we're going to keep going back to our diagram to get comfortable with it. All right, so our first question being posed to us is, let's say marketing wants all customer names and their email addresses. They want to send out a marketing blast to all of our customers. So we'll look over to our diagram real quick. We'll find our customer data, and they have first name and last name. It's in the customer entity or table, and they have the email address. Okay. They also have an active column. Now, marketing didn't say if they wanted active or not active, so we may want to focus in on that. We might want to come back to the marketing and say, do you want the active customers? Do you want all customers? Do you want inactive customers? So that might be important to us. I'm going to bring that back in my query. Okay, so I'm going to go first name, last name, and email address or email, and then we're going to do active. So if we do select first name, last name, email, active from customer. Okay, and we'll put that semicolon to end it. So this is from our table name. We'll highlight that line and get our results, and you'll see that we have 599 customers. Okay, we scroll down, we just look at the data. We see mostly ones. Ones are going to be true, zeros are going to be false. So let's say we reach out to our marketing resource who asked us for this information. They say we only want active customers. Well, we don't want to accidentally contact inactive customers, so let's build this up and go where active equals 1. It's a Boolean, true or false value. Okay, so we'll make a little correction to this where they are active only. All right, another good skill as a data analyst that you, as you're working with SQL, is to always ask questions. Don't make assumptions. If they don't give you all the details and you're not sure, because what could go wrong here is if we didn't ask, we gave the list, we'd be contacting inactive customers, and that's never a good thing, right? You always get emails saying, well, we accidentally sent that to you, we didn't mean to, right? So we want to, market to our active customers. All right, so let's move on. Our next question is list the titles and rental rates of all the films. All right, so not really sure, right? What do I have to do? So let's start looking in our diagram. Titles and rental rates, where can we find that? Let's look over to inventory. Sounds like an inventory item. Title, it's in our film table. Now what about this rental rate? Oh, there we go. It's right there in that film table, so pretty easy. And if we just look at the table, does anything else stand out that might be important? They just want to know the price. It doesn't ask, there's no other real information here that might be of value for the time being. So we'll just go forth and we'll write that query. Okay, so we'll go, this one's going to be pretty simple. We'll just do select title, rental rate from film. And we'll highlight that one and run it only and do execute. And you're going to see that here's all of our titles. We have 1,000. Actually, we have more than 1,000 records because we see here it triggered limit of 1,000. Our editor is set to only bring back 1,000 records. So keep that in mind. If you were to take this data and right click, copy it, highlight it, you're only getting 1,000 records, and there's more than that because it shows you the limit 0 and 1,000, and we didn't get a full setback. So just keep that in mind. Using this, you may have to use commands to get more than that. There's this little clicky here for fetch next frame and see what's there. I'm curious to see what's actually in that table. So, because we see that 1,000 records were returned. So let's just do a select count star from film because we want to make sure we bring them back all to our requester. So that count statement is a built-in function. We'll see that later on in the next query coming up. Asterisk means just count all the records. If we execute that, and just out of coincidence, you'll see that it has 1,000 records. So we didn't miss any. So when I click that little button over here before to show the next frame, there were no additional records. So that to me was concerning because it said 1,000 returned and the limits of 1,000. But we verified only 1,000 existed, so we will be safe there. Now, going back to that query, let's make that just a little bit more complex, and let's say order or sort the results from most to least expensive. All right. This order by clause in SQL is going to help us do that. So how would you use an order by clause? Well, pretty simple. Order by whatever field, which will be rental rate in this case. All right. And then there's a direction. By default, if we run this command, it's going to be lowest to biggest, so all the 99-cent titles, all the way up to the $4.99 titles. But we want the ones that are most expensive. So ascending, which is ASC in SQL, is the default. And if we ran this again with ASC, you'll see, there you go, okay? But descending, DESC, is going to go from highest to lowest. All right, so you'll see the $4.99s are now at the top. Now the next thing that people might like is to have the titles in alphabetical order and as a subsort. So secondary sort on title. Again, presenting your results is always something to consider for your end users as well. So put a comma in and then do title. And you'll see your primary sort will be descending, and then your secondary sort will be ascending, because again, it will automatically fall to the default. So if we say execute that, now Ace Goldfinger, AC comes before AI, and if you go right down the list, so there's a first column here, everything's sorted, and then the second column is sorted. So that's how you order your results in SQL. Order by. And you can have multiple fields in multiple directions. Very common to do that. A lot of times you'll do that by like city-state sorts. Quite possible. All right, moving on to our third question. Count the number of films in the inventory. All right, we need to know how much we have available. All right, remember that count statement? So it's pretty simple. If we go back to our diagram and we look over at our inventory table, we have just basically film ID in there. It's not asking us any data about what films and anything like that. So we can select count star, just like we did on the film table, count star from inventory, and that's going to tell us how many films we have in inventory. And we have 4,581 films in inventory, which is pretty interesting. It makes me wonder. We had 1,000 films in our film table, but we have 4,581 in inventory. Let's look at our diagram again. Let's ask why that might be. Well, why is that the case? Well, check it out. In our inventory table, we have this secondary foreign key called store ID. So a film ID can exist multiple times in inventory because it can be located at different stores. So we can tell that our database consists of multiple stores out there. Okay. So we might ask ourselves again, when we're reconciling our values, you might say to yourself, well, in this query we only had 1,000 records, but in this one we had 4,500. Why was that the case? Well, go back to that diagram like I said, and you see the store ID and that film ID indicates that's the case. That's why we have an inventory table, because a film can exist at more than one store. And maybe a film may not be available at a certain store for some reason. All right, let's find the total amount spent by a specific customer. Why might you want to do this? Well, because you might want to know how much a certain customer's value is, or analyze your underperforming or your best customers in your system. So maybe you want to look at, maybe an angry customer, he calls and complains, and you should have great customer service and make all customers happy, but perhaps maybe the customers who don't spend a whole lot, maybe under $500 or a lifetime spend of $1,000, maybe we're not going to be as courteous or follow up with them if they're upset. I mean, we want to really retain our best customers, perhaps. Or maybe we want to market to our customers who are not, spending as much. So let's see how we can do that in SQL. What we're going to do here is we're going to look at our diagram again, and we're going to figure out how do we tell what customers spend. We don't see anything in the customer table about spend here. We follow the lines coming out of customer, and we see it comes down to business. And if we follow down to business, we'll see that our customer goes out to this payment table. All right. So here in this payment table, we can figure out that the customer ID is there, and then the amount that they spent. So all the payments that they made over time is going to be important to us. So we want to sum up that amount from that payment table. Okay, so what they're asking for is customer ID of 1, for example. Now, we must know who customer ID of 1 is, so we're not going to have a join or anything like we saw last week right now. We're just going to have a simple query. So we're going to do select customer ID, and we're going to sum, using a built-in function, again, another SQL function, that amount column as total amount spent. Whenever we have a function, we can have it come back in a column that's meaningful. So if you saw that count star before, we see that just came back as count star or count asterisk. That's not really meaningful. What we can do is we can alias that function result into a column that's meaningful. So total amount spent would be meaningful. So remember that using aliases makes your output even better. And we're going to do this from the payments table. Okay, so we're going to do this from payment. And we're going to do this with a where clause, where customer ID equals 1. Okay. And now because we have a sum, and we're looking at this particular customer, we're going to need a group by, because we have additional field in that query now. So whenever you have more than one field in a function, you need to group by those fields. So group by, in this case, group by customer ID will take those records for that customer and merge them together, totaling up the amount column. Let's hit there. And you'll see that this customer spent $118.68. Let's change that up and let's find who the customer is that has spent the most amount of money with us. So let's take that where clause off for a moment. And let's order this result by total amount spent descending. Use that order by again that we saw recently. Customer 526. That is our best spending customer, $221.55. Okay. Remember last time when we did a join? Can we figure out who that customer is from this now? You guys want to pause this and try it out? I'm going to go ahead and do it. I'm going to do inner join customer on payment dot customer ID equals customer dot customer ID, and let's bring in that first name, last name. Let's bring in that email. We're going to send them an email saying thank you. Okay. Basically, we have that first query that we had earlier now with that amount that they've spent here, right? And let's also bring in active. Let's make sure they're active because that was important to us, right? Now, remember last time I said if we didn't specify the table that fields came from, if any of these fields overlapped, we'd get an ambiguous error. So just for the heck of it, let's make sure we put our table name in front of each of our columns just to rule out any risk of things being ambiguous. Okay. And then the amount spent is good because that's our clause here, but we want to put that in front of the payment dot amount. All right. So now let's see who that customer was. Let's see if they're active. A little bit more complex. Oops. We didn't put our where clause in. We got all the customers, but we see that Carl Seal, he's our best customer, and Eleanor Hunt is a little bit behind, you know, and then we can go all the way down and we can see our worst customers. So we have a customer list and what they spent now. And now again, this is active and inactive, so let's not forget our where clause. So after our from line, where active equals 1, and let's say customer ID equals, let's go back to that number 1, that original question. So we now brought in the customer information with the amount that they spent. Oops. And I made a mistake. Let's see. Column customer ID is ambiguous. So what did I do? Okay. So for those of you that have been paying attention, I, in my where clause, forgot to put the table names in front. And the one that customer ID overlaps in both tables because the foreign key in our payments table. We will correct that. We'll actually put it in front of both and we'll execute it. And now you'll see there's Mary Smith, $118. Okay. So we took the simple question and we enhanced it by providing some additional information. All right, let's find out who the customers who have rented a film in the last 30 days. All right, this is going to be a join condition, and we're going to look at the customers, and we're going to look at the rental table in this case, and we're going to look at the rental date in this case. We're going to join these together in this case. All right, so we're going to figure out that we want to get information from the customer, so we're going to take some stuff from before. We're just going to take that select list. A lot of times our queries can help us with future queries. And this is the information about the customer. That's all going to come from the customer table, of course. We're going to inner join that rental table this time. And we're going to do that on customer.customer ID equals rental dot customer ID. So foreign primary key to foreign key again. And we're going to do where our rental dot rental date in this case is greater than or equal to we want to use some built-in functions here. This is where we can use the power of the language. So we're going to do curdate, which is a built-in SQL function for MySQL. This will vary in different SQL platforms, but curdate is for MySQL. And then they have a command called interval 30 day. So this will tell us, basically, take the current date and take 30 days away from it in MySQL. Cool little trick. If you've never worked with MySQL before, it's very different if it's Oracle or SQL Server, but this should work in MySQL. Let's run this command. And we have no customers in the last 30 days currently. Well, likely that's because this data in this database is really old. So if we just take a quick look, just so we can show some results here, select star from rental, and let's see how old the data really is. All right, 2005. Wow, we'd have to go back almost 8 years or more, potentially, to do that. So it would take us a challenge to get that information. So let's say anybody who has a rental date just for fun, can we do a large number? Oh, this 10,000 days should cover it. There we go. 10,000 days covers it. I got 17 customers, I think is your result there. Actually, nope, not that 17. You have 1,000 records returned. But you're going to notice that if you were to order this result here, order by first name, last name, you're going to see that you're going to see customers' names here multiple times because customers have rented more than once, like Aaron Selby here. So we only want the customer one time, and that's why I wanted to show results here. We need to use this command called distinct. What distinct will do, it bring us back just the unique values. All right, so whenever you want to return only one occurrence, when there's multiple occurrences of something, use distinct. And there you go. So again, you might also want and active or customer.active equals 1 because you just want to deal with active customers. So if marketing wanted to reach out to these people and say, hey, thanks for renting the last 30 days, please come back next month and do it again, right? Or in this case, sometime in the last 1,000 days. All right, list the top 5 most rented films. How do we do that? This one's going to be more complicated. We need the film title. We need to know the amount of times it was rented. We're going to need to know things from the rental table, the inventory table. There's going to be a multi-table join. So we have 3 tables. We're going to have 2 join conditions. We're going to go into our diagram. We're going to look at the rentals. We're going to look at the inventory. And we're going to look at the actual title, okay, from the film table. So take some time to explore that, pause that, and come back. And meanwhile, I'm going to show you what that query is going to look like. I'm going to do things a little different with my table names this time. I'm going to use a thing called an alias. And as I type this, I'll explain it to you. So I'm going to use the letter F for every time we get something from the film table. F.title is going to be the film table. I'm going to count from the rental table the rental ID. Okay. As rental count. From film, I'm going to reference that as F. That's an alias, okay? We can alias things so that we don't have to type the word film out all the time. So up in that prior query, I typed out customer all the time. I could have used the letter C and then just referred to it as C all the time. So that's a neat little trick. So we're going to use film F, and we're going to do inner join inventory I on F dot film ID equals I dot film ID. And then we're going to inner join rental. We're going to call that R on R dot rental ID. Oops, sorry. R dot inventory ID is what I meant. Equals I dot inventory ID. And we're going to now group by F dot title, okay, because that's in our select list. And we're going to order by our rental count field, our result field, and we're going to do that descending. And we want only the top 5. So I haven't showed you how to do that before. If you notice down in our results, you saw the word limit come up sometimes down here in the output. That's how we do it. We use the word limit. Limit the results to only 5. All right. So let's see how this does. Our top 5 rentals. Bucket Brotherhood rented 34 times. Rocketeer Mother 33. Forward Temple Grit. So if we were doing a leaderboard in the store and we wanted to see the most popular rentals, these would be the most popular rentals of all time. Okay? We could have a live leaderboard updating all the time. All right, find the average rental duration for all films. All right, again, potentially pause this, come back after you check it out. Rental duration is going to be over in your film table. All right, for some reason we keep it there. I don't know why we would keep it there from a business perspective, but something must create that and keep it up to date. All right, so if we do select AVG rental duration as average rental dir from film, that should give us the data. Average, another built-in SQL function, rental duration, and then the field we want to result in. Pretty simple on this one. 4.98, okay? Looks like number of days, 4.98 days. Get all the films that are available for rent. All right, this one's pretty easy. We can do select title from film, and we can do where film ID in or film ID not in, sorry. Select distinct film ID from rental. All right, so what this means that we want to find any films that are currently not out and rented. And in this case, none come back. Okay. Now, curious though, is that accurate? Or maybe that's inaccurate. That just tells me that every film we've had has ever been rented before. So I'm going to leave that query here for you to look at because this is not accurate because we have inventory, right? So we probably need to find out if there's anything currently in inventory to get that answer correct. If you look in inventory ID, potentially, and if the return date is not filled in, if it's null, you see how it's a diamond that's not filled in? There's a way to do that, but I'm not going to do that for you here. It's a more advanced query, but I want to let you figure that out. And if you figured this one out, and if you're watching these, put it in the comments, and I'll comment back to see if you're correct. So, how can this be corrected by using inventory and checking for nulls in the rentals returns? All right, we'll leave that back. That one's a little bit more challenging. What about the inventory by each store? We're going to work the store into this time, and the staff table into this as another approach. So we're going to do our revenue. We're going to look at that amount, and if we look at that diagram again, if we say, oh, we have to figure out store and the actual amount that's being actually collected here in payment, how do we get from store to payment? Well, we have to go through staff. This one's one of those complicated ones because store and payment aren't tied together. Staff is tied to store and tied to the payment. Okay, so let's see how this one works. Again, pause it, try it out, and then come back. But we're going to do select s dot, I'm going to use that alias, store ID, sum p dot payment, or sorry, p dot amount. That's going to be from the payment table as total income from store. And we're going to do from store as inner join staff, and in this case we will call that st for staff on s dot store ID equals st dot store ID. And it's bothering me because this is underlined right now because I never put the semicolon, or sorry, at the end of that line. Okay, we'll fix that. Inner join our payment table P on st dot staff ID equals to P dot staff ID. And now again, because I have a field coming back, we got to do a group by s dot store ID. And then let's order this by the best producing store, order by total income from store. All right, so let's run this. Let's see what we get. If you run it right, you're going to get store ID number 1 has outgrossed store ID number 2 so far. Cool. One last query. Let's figure out the customers who have not made any payments. Well, this one's going to be pretty easy. We do select star from customer, where customer ID not in. Remember that subquery we did last week? Select customer ID. From what table was it that we talked about earlier? See, as you work with the database, the tables will stick in your mind. It's going to be payments. Okay, and fix my typo here. This will tell us any customers who have not made payments. And I made a problem because it's not payments, it's payment. Again, once I thought I started to remember the table names, I still was incorrect. It's actually just payment, I believe. So let's try it again. And in this case, every customer has made payments. So there isn't no customer in this case. How can we verify that? Let's verify our results are correct. So let's take the not in. So let's do select count star from customer where the customer ID is in the payment table. $5.99. And then let's just do select count star from customer. We want to see if they reconcile. $5.99. So every customer has purchased something or at least rented at least one time with us. All right, so we can tell marketing there's no one to reach out to. I hope you found these examples useful and helpful. As you can see, there's a lot to working with the select statement. A lot of complex scenarios that can come up, a lot of business questions that can be asked. If you go out into the World Wide Web and Google, you can look for additional questions. There's actually websites out there with this database. You can just go out there and go to Google and say, hey, give me some sample questions to ask of Sequila. I'm going to actually share with you how I got these questions. And these questions all came from ChatGPT. I asked them earlier, and ChatGPT gave me a list of questions that I could use for this. Okay, I said, give me 10 simple queries. And that's exactly what I did there. All right, I hope you found this valuable. Please come back for the next lesson and subscribe if you haven't already. Put anything you have in the comments and I'll respond when I can. Thank you all.